Welcome to a Celebrity Life activity, which is for your enjoyment and education and just for sheer fun on some of these things. So, here we go. I need a shark fin to come across the stage now as a special effect. We couldn't. Oh, there we go. Thank you very much. There's the shark fin. Well done, darling. Thank you so much. Of course, you all recognize that music, I hope. That's Jaws, which gave sharks a really bad reputation. I always like to begin with something funny, and this was a picture that was given to me by a passenger. It was taken in Hong Kong. If you can't make it out, it says shark fin makes your penis small, very small. Because, of course, shark fin soup is something that we want to avoid now because it's really having an impact on the shark population. I won't go through this. I want to spend time talking about sharks. Where did this word come from? The etymology of shark. Well, we can find it in documentation in the past. So let's start here. 16th of June, 1569. There was an account in a one-piece sort of newspaper. It was a broadsheet. And there's the word shark. You may not recognize it because the S looks like an F. That's how they used to write it in those days. But from the description and the picture that was published there, it was obviously a thresher shark. It was a 17-foot thresher shark. And once it had been cut up and sold for meat, they actually stuffed the remains and they had it mounted in a pub for a while so that people could go and see it. So there we go. Back as early as 1569, we have the word shark. Is that the earliest? Well, we're not sure. We'll go back in a minute. 1604, we have a translation of a Spanish account of the ravening tiburons, or sharks. That's from the Spanish. It's an interesting word. Shark comes from shock, which is actually a Mayan word. Well, this was recently identified in this paper here in 1983. It's the only Mayan word that has come into the English language and is associated with shark. It's also defined in a dictionary as early as 1689 as being somebody of less repute, or not a very good repute. A knave, in other words. Shifting knave. Then we have this very interesting correspondence here from Thomas Beckington. It wasn't published until 1872, that's the date down there, but it was actually written in 1442. And this is an account of King Henry's secretary, and he was also the bishop of the time in England. And this is the text that comes from this, and there's the word shark. So 1442, that's 9 years before Columbus was born. So exactly how they came up with the word shark is now becoming a little bit more difficult to figure out. So in fact, if we try and find the origin, really it's obscured and it's now lost in the mists of time. So we don't really know where shark came from. We're all aware of man-eating shark, but you know you can interpret that in a different way. Man-eating shark. You got it, right? Okay, good. That's my shark joke for the day. Finished. You can swim with sharks. These are black tip reef sharks. There's some divers there. This was taken in Bora Bora when we were in Bora Bora. I took out a very large insurance policy on my wife, hoping to make some money, but unfortunately it didn't work. There she is there. There's the sharks, and they turn out to be pretty friendly. Yep, there we go. She's still with me, and I wasted the money on the insurance policy. Oh, well, there it goes. There, these are more pictures from Bora Bora. Here's my wife again. The guide took a liking to her, so he enticed the rays with some food to go all over her. And have you felt rays? They're slimy. And so there was some wonderful screams, which I couldn't capture because these are still pictures. But nonetheless, that's Bora Bora if you ever go there. So where did they come from? They go back to 450 million years ago, which of course is a large number. This is when sharks were there. So they've existed longer than a lot of different things on the planet, including ourselves, 3 times longer than dinosaurs, and they have survived a number of mass extinctions, as I'll show you when we go through this. They are really old. They predate trees. They are older than trees. This is the first tree that's been identified. It really isn't a tree like you understand tree today. It didn't have leaves, it had fronds, and that goes back 385 million years ago. So sharks, way older than trees. These are some contemporaries that go back. So there's the shark. This is a nautilus. This is a horseshoe crab, and this is a jellyfish, and you can see how old they are. So they date back to about the same time as when sharks evolved. This is the evolution of sharks. This is the group, that's the common ancestor. And where you see a line here, that's the number of families in it. The width of that line tells you the number of families in there. And families contain species, so there's lots of different creatures in the families. These are the sharks up here. And the extinctions are shown here by the red lines, and you can see that the sharks and their ancestors have survived those extinction events. Looking more at extinctions, we have a very large extinction here, and then there's the one that killed the dinosaurs. That extinction there, about 275 million years ago, wiped out almost everything, 90% species, 90 to 80% species. And then the dinosaur one there, about 75% of species. Sharks have survived that. We believe we're in a 6th extinction now, which is this one, which is, of course, due to us and the way we're changing the environment on the planet. So here's an unusual one in the path of evolution. This is a reconstruction. They're not 100% sure of how big it is, but there's the human, there's the shark. But look at the mouth. That tooth structure has survived, which is how they've reconstructed this one. And as you can see, it was quite a big animal, lived about 300 million years ago, went extinct about 250 million years ago. But it's like a rotary saw inside the mouth is the structure of it. Then there's this unusual one that was found during the evolutionary tree. This is a male. It had this unusual sort of bony dorsal fin, which has survived. The female didn't seem to have it. And as you can see from the picture, not a very large shark, but this is also one of the odd ancestors that has come and gone through evolution. So how many? How many different species of sharks are there? You could probably name off a few, but I doubt you'd be able to name them all because there's lots of them. Let's go through it. This is the class under which all the sharks are held through the different orders and different families. So there's 9 orders, and there's 4 that have gone extinct. This is an odd one here. This is the Japanese angel shark, which is part of this family here. They're very flat, and as you can see, we are in that part of the world right now. If you're going to go swimming, you might see one at the bottom. So as we look at the taxonomy, we come down from the life versus no life, through the different divisions until we get to the class that contains all the sharks. There's 8 orders. The 9th is the skates and rays, which are related to sharks. Then there's families. We go down to the genus, and finally to the species. There are about 536 species, so there's lots of different sharks of all shapes and sizes. And this shows you how it's broken down. And the way these things are related to each other is through physical structure. So the number of gills the shark has, whether it has a dorsal fin or not, and other such things is how they group them. Now, of course, it's being done by DNA, but in the early days it was based on physical structure, and that's still a large extent true today. So there's more than 550 species in the oceans, so if you're scared of sharks, don't go in the oceans. That being said, you can find some in rivers too. This example here, the spear-toothed shark, is found in northern Australia and New Guinea. But there are other rivers that are infested. Well, maybe infested is too strong a word, but you can find sharks in other freshwater places, and I'll get to that later. 2018, we actually found a new species. It's shown here in the pictures. This is the tooth structure. It is related to its Pacific relative, but it is sufficiently different to be classified as a new species. So this one was found in the Atlantic Ocean, and you can see how big it is. It's not particularly big as far as sharks go. They have some very odd relatives. This is a chimera. You can see it looks very strange. They are also related to sharks, as the skates and rays are. So if you like, they're cousins. This is the elephantfish chimera, or the Australian ghost shark is its other name. You can see it moving here in the animation, and it really does look quite odd. Then the skates and rays I talked about already, the cousins of sharks. A couple of pictures there to show you what they look like in case you don't know, but I'm sure you're all familiar with those ones. So anatomy of a shark is based into really three sections. You've got the head section, the trunk section, and the tail section, and we've named all of these different parts of sharks so that we can compare one shark to another. I really don't have to go through that in detail. You can have a look at that for yourself. That's the thing, of course, it's notorious, that dorsal fin there. You know, you see that coming towards you in the water, and then you worry, especially if it happens to be one of the four major types that like eating meat. Well, we'll get to what they eat in a minute. When I say eating meat. These are the main features of a shark. Of course, they have cartilage, they have no bone, which makes looking for fossils difficult because there's no bone to fossilize. They are, of course, fish. They have gills, they absorb oxygen from the water. Most of them are cold-blooded, but there's a few that can semi-regulate their temperature, the great white being one of them. Some lay eggs. Some don't, they give live birth, we'll see that in a minute. And interestingly, their teeth are constantly being replaced. So they lose a tooth, there's a new tooth behind it. So they're never without those teeth, unfortunately. You're never ever going to get a nasty suck from a shark. Swimming. They can't swim backwards, unlike other fish, they have to keep swimming forwards. Some of them use their tails for the propulsion, others use their body. So the whale shark, for example, it moves in a slightly different way, and it's the muscles in the middle here then that do that. Their pectoral fins at the front are just like aerofoils on planes. They're going to change the direction. And then you've got the pelvic fins acting as stabilizers in the horizontal direction, and you've got the dorsal fins helping them stay in a straight line in the vertical direction. So that's how they swim, and they can swim quite quickly. They have very low friction on their body. Their skin is covered with these scales which allow water to move over it very easily. They all have different tail shapes that help them move through the water in somewhat different ways. So that's what the tail shape looks like. And these placoid shales, as I say, allow them to move very quickly. They are fast swimmers, as you'll see when I get to speed compared to us. This is how big they are. So there's a human up there to put things in perspective for you. This scale here goes up to about 12.2 meters, or about 40 feet. There's the tiger shark, the Greenland shark, the great white. It's not the biggest. There's the basking, and there's the whale shark. Yes, the whale shark is a shark. It's not a whale, and it is indeed very large indeed. Now, how about small? This is the spined pygmy shark. As you see, about 11 inches, so that's about the size. Is this the smallest? No, it's not the smallest. We actually have one that's smaller. This is the dwarf lantern shark, and it is located to a very small area here in the northern tip of South America, and it's only about 8 inches long. So shark, only about 8 inches long. You're not really going to have very much trouble with something like that. This is the largest, this is the whale shark, and you can see from the stats there, very big indeed, up to 21 tons in weight, the largest non-cetacean animal, whales of course being bigger, but they are mammals. This is the largest non-cetacean animal in the sea. This gives you an idea of the speed. Here's a human. An Olympic swimmer can go about 5 miles per hour. So this is the average speed for sharks. It's a little bit lower than the human swimmer, but as you can see, this one up here, the short fin mako, can go up to about 70 kilometers an hour over short distances. So you see one of those coming towards you, there's no way you're going to outswim it. They can go particularly quickly. And there's the great white. the one that you should be worried about if it happens to be hungry. More about great white later. Can they jump? Yes, they can. And this picture shows you roughly how high they can go. Why do they do it? Well, it's sometimes to get some food. They might see a bird on the surface, and the bird is now a breakfast or a snack. And other times they just seem to do it. We don't really know why. I mean, this one here can go really quite high. And imagine the power of the great white there, lifting that weight out of the water. And you'll see an example of that in a minute when we get to that section. Diet, most of them are carnivores, and the rest of them are, what do you think? Carnivores. Well, there is one exception, and this was just recently discovered, actually. Last year, this particular one here, the seagrass, digested by this notorious carnivore, it's an omnivore. So in addition to eating meat, protein, it's also eating some seaweed. So we've only just discovered it, 2018. So yes, not everything, not all sharks are going to eat meat. This is the basking shark, and it feeds in a very similar way to whales. It ingests a great deal of water and then expels that water, extracting about 2 kilos of food at a time when it does that. And you can see there's a diver up there, so you get an idea of how big that mouth is on the basking shark. This was discovered in 2013. They don't know why they did it. There was a huge grouping of these sharks off New England. As you can see, well over 1,000 sharks congregated together. Why? Nobody knows. Does it happen frequently? Nobody knows. Another mystery of the sea. Teeth come in different shapes and sizes. This is the great white down here. There's the megalodon there. The megalodon was a much bigger fish than the great white, and despite the film The Meg, there are none left. They went extinct a long time ago. And as you can see, there's some other teeth shape there, and they're used for slightly different purposes. You see that one serrated almost in the cow shark, mainly to hold slippery fish. This is a great white jumping, and there is a tooth. An amazing picture. This tooth has come out. They will go through about 20,000 teeth in a lifetime, having about 300 at a time, and they have rows of teeth. Next row waiting to come in, and there's another row growing behind it, and maybe even another one growing behind it. And this gives you an example. Here's the first row of teeth, there's another row of teeth, there's a third row of teeth, and you can see down there, even at the bottom, there's another row of teeth growing. So you can see up to 5 rows of teeth sometimes with these sharks. Digestion. This is the inside of a shark. Obviously, food goes in here. They've got a strange U-shaped digestive system, and most of the food is processed in this area. And so this is the way it works. We've got strong enzymes in the stomach. Anything indigestible is vomited out to the left, and anything digestible is processed through the shark, and it gives it its energy. Counter shading. If you look down on top of a shark, it's dark on top. If you look from underneath the shark, it's white underneath. This makes it harder to see. This is called counter shading, and it has evolved to make it a more secretive predator, if you like, so that its food can't see it coming. Eyesight, they actually have color vision. They do have rods and cones. They have almost 360-degree vision, so you can't really sneak up on these. If the water's clear, they can see about 15 meters. If you don't think in meters, think yards. That's how far they can see through there. That is not their most sensitive sense, as we'll see as we go through. They can see better than we can in dim light. Of course, you know, the light is lower in the sea, especially as you go deeper. So they've evolved the ability to see well. Hearing, they can detect prey as far away as about 240 meters, that's 800 feet. It's also used, the ears are also used for balance, so they know to stay on an even keel. They have a much less wide range of hearing. We go up to about 20,000 hertz in our hearing range. They only go up to about 800, so they have a very limited hearing range from 10. We can't hear 10. We go down to about 20, so their range is restricted, but also outside of our range. Smell, very good smell indeed. They're sometimes known as swimming noses. They can detect blood at a concentration of 1 part per million in water. They can detect fish extract as 0.1 part per billion, which is 10,000 times more sensitive than detecting the blood. They can smell small amounts of this hundreds of meters away, so it's very sensitive indeed. If the water current is taking that material to them, they can detect it in the water current. Taste, not well developed. They don't have that many taste buds. So how they decide whether they like something or not, they do a taste test, which means they bite you. If you get spat out, they didn't like you. You didn't taste good, which actually happens to most people. People aren't often eaten by sharks, but unfortunately a shark bite can be pretty severe, so you may die of complications afterwards if the bite is bad. But yes, they use their bite to investigate something. They are actually quite curious creatures, and that's one way they sample what it is, figure out whether they want to eat it or not. The bioelectric effect, if you like, the bioelectric sensors, which you see are all over the shark's head here, and in fact down the body too, were discovered a long time ago, but were not understood until fairly recently, 1962, and then refined again in 2003. What do these bioelectric sensors do? They detect electric fields in the water. We move by sending signals through our nerves, as do any other animal, any other living creature, and that actually is an electric current, albeit very low. That generates an electric field. These sharks can sense that electric field. So how sensitive is it? They could detect a 12-volt battery 12 kilometers away. That's how sensitive it is. They're not the only creatures that can do this. There are other fish that can do this too, but this is probably the most well-refined. They've also got pressure sensors all the way down the side of their body, and this tells them, gives them information about depth, also the way that the water is moving. They can sense vibrations coming through the water with these pressure sensors. So these things are highly instrumented, if you like. They're very well evolved. This is a complex diagram. Let's just concentrate on the top. So the odor is the first thing that they'll see. Then they may detect some wake turbulence in connection with the odor, so that's using those pressure sensors that I spoke about. Then as they get closer, they can actually see the target. Then as they get closer again, they'll detect the electric field, and then finally they'll touch the target, and a touch the target could well be just a bump, or it could be a bite, or it could be dinner. And depending on the condition of the water, different strategies come in place for different conditions. They cannot speak, of course. They have no vocal cords. They can't vocalize. That being said, there's two types of shark that can bark, and it's believed that they're just getting water trapped inside in their GI system. There's the swell shark, which you find here, and the draft board shark that you found down there. So they can make sounds if they're taken out of the water, not in the water. Breathing. It was once thought, and I think some of you may think, that if they stop swimming, they stop breathing. Is that true? No, not for most of them, but it is true of some of them. Some of them do have to keep swimming to keep passing that water over the gills to take the oxygen out. So, 24 species have to keep doing it, and I've listed them there, and one of them is indeed the great shark, the great white. It's got to keep moving to be able to have the oxygen passing through the gills and extract it so that it continue to breathe. So you see there the water's coming in and it goes out through the gills. There are certain circumstances where they don't have to do this if the water is moving in the right way. Well, I'll get to that in a minute. This picture I took when we were in New Caledonia. This is a zebra shark. It's lying on the bottom of the tank. And of course, I thought, well, sharks have to keep moving, right? This is clearly not moving. And we were a little bit worried. We thought we better go and inform somebody that this shark had stopped moving and it looked like it had expired. In fact, what this shark was doing was having a rest after mating. They get tired and they have to take a break. So this is the equivalent of a shark having a cigarette, if you remember that reference in films some years ago. I'm dating myself. When they mate, they have claspers. You see them here. They tend to bite. They bite their mate to hold them in place, so you can get scars, as I say there. And the gestation, of course, after the mating has taken place varies depending on the species. I've listed some times there. In general, when you're looking at sharks, the females are bigger than the males. When they give birth, they can either do it live birth or they can lay eggs. These are shark eggs here. We call the young shark a pup. And here it actually is a live birth taking place underwater, an amazing shot. And here is an embryo in one of the egg sacs, also known as a mermaid's purse. Do they sleep? Not as we understand it. Obviously, they do have to rest in some form, but when you have to keep moving, part of the brain is still working to keep you moving. So no, they don't sleep as we understand it. They don't sleep like mammals or ourselves. They don't need 8 hours a night or 6 hours a night or whatever we do, but they take a little rest period. That being said, we have this very interesting place here off Cancun known as the Cave of Sleeping Sharks. This wasn't discovered until 1969, and if you go into this cave, you'll find sharks seemingly asleep in the cave. They're not moving. They're generally nurse sharks. Somewhere, this cave is about 20 to 30 meters deep, and they're just lying on the bottom. And the currents there are actually taking water over their gills, so they're able to take the oxygen out without actually moving. This is what it looks like. Kind of eerie if you were to go in there and find all these sharks just lying around. You wouldn't want to wake them up, right? Lifespan depends again on species, so I've listed some of them here. There's some uncertainty about the great white, of course. Could go up to 100 years. You see the whale shark here also going up to 100 to 150 years, so it's very much species dependent. That being said, then there's this one, but we'll talk about that one because that's a special case. Buoyancy. Now fish have a gland, they have an air sac which they can use for buoyancy, so they cannot change depth very quickly. If a fish changes depth very quickly, it could literally explode. This is not true of sharks, so although they're fish too, they have what's known as a swim bladder, which is, they don't have the swim bladder, so they have a liver that has a lot of oil in it, and that oil has a low density, so it gives it some buoyancy. So the shark then can change depth very, very fast, which makes it a great hunter. This is the material that's actually in the liver. That's the density there. Water is 1, so you can see it's lighter. It wants to float. And depending on the amount of oil they have in their liver, that's the amount of natural buoyancy they have. So with their powerful muscles, they can dive quite deep and they can come up very quickly if they see something above them. How smart are they? This chart here is the encephalization quotient, which is a measure of intelligence. It's not just based on brain size. There are other factors to come up with this encephalization quotient. So here's the human, and on this one, these are the sharks. So here's a dog by reference. There's a cat. You can see the crocodile sharks up here. There's the orca, and there's a couple of dolphins there. So some of these sharks, yes, they're pretty smart. Difficult to give an IQ test to a shark, but there's other ways that we can do it. We can look at what they do. They are strategic hunters. They can cooperate, and they do learn by mistakes. And in fact, you can condition them, you can classically condition them much faster than you can classically condition a cat or a rabbit in terms of intelligence. So yes, they do learn. As I mentioned earlier, they're curious and they can work together to achieve a goal. So this shows some form of intelligence, but of course, living in the sea as they do, it's very hard to measure. So this is a myth that sharks don't get cancer. Yes, they do, and this is the evidence in fact shown in these two panels. This is a malignant cancer in panels A to C. We're zooming in all the way down, so the cancer's up there. There again, it's shown there. There's the cancer cell and there it is here. And on this side here, it's a benign cartilage tumor, again shown at different levels of magnitude. So yes, sharks do get cancer. This is the bull shark, and this is what I just added. Thank you very much to the conversation this morning. This is a very unique shark because it can live in both freshwater and seawater. This is the range here in blue, and as you can see, it can go all the way up to the Amazon, which is about 2,600 miles. That's a long way for a seawater creature to go. How do they do it? It's a process known as osmoregulation, and they are able to change this gland, if you like, so that they can deal with both freshwater and saltwater. They're not alone in this. There's 43 other species that can do this in the class of animals like sharks, and these are pretty dangerous. They're classified as one of the world's most dangerous sharks. They eat mostly fish, bony fish, but they also eat other sharks, and they will eat dolphins and birds, and basically anything they can find, so you could be fair game. But that being said, want to go feed one? These are pictures of people feeding bull sharks. If you want to do this, go to Fiji, because there is a company there, which I've listed there, Aquatrek, that will take you diving and let you feed bull sharks. There are 8 other types of sharks there that you can interact with without a cage between you and the shark. And apparently they've had no problems since they've been in operation. This is a tiger shark. The study on a tiger shark, they looked at 628 different tiger sharks and found 192 different items inside the tiger shark. Out of those 628 sharks, they only found evidence of human remains in 2 of them. So they don't eat a lot of people. In fact, over the last 400 years in tiger sharks, there's only 32 reported cases of human fatalities with a tiger shark. So they don't really deserve their fearsome reputation as man-eaters. So let's look at some weird sharks. We already looked at that one when I was talking about evolution. So here's the other one. This one you're probably familiar with. This is the saw shark. There's the saw blade. It's used to slash and disable prey. You'll find this around the world. Well, we're in the right area. It is around Japan. So you might find those in this area, but they're down at the bottom generally. You're not going to find them at the top. This is the thresher shark. We've known about this for a long time. It's actually mentioned by Aristotle in his Historia. It was once thought that that tail was used for slapping the prey and making it unconscious. That's not true. It is used to propel the shark very quickly. It doesn't use it to stun its prey, as was once thought. And you'll find it pretty much everywhere. This is the cookie cutter shark. You don't want to meet this one. It's called a cookie cutter shark because that's what's left after it's taken a bite from you. It's like a cookie cutter bite. So here you see what it's done to a fish, and look at those teeth. That being said, it's not particularly deep, but what's unusual about this shark is it will go from very deep to very shallow as it migrates during this 24-hour period. It can go as 4 kilometers deep, and the pressure down there obviously is very high. And there's no light whatsoever when you go that deep. And they will go up and down, looking for food. This is the woebegone shark in the Australia-New Guinea region. It's there. It sort of looks like floor material. It's very well camouflaged. It is the only member of its genus, meaning there are no other species in that genus. So it's quite unique in that respect, the woebegone shark. This is the frilled shark, also known as a living fossil. It looks pretty snake-like, but it is in fact a shark. It's about 2 meters long, which basically means it's my height. I'm just under 2 meters. And as you can see, has lots of teeth, 300 teeth, give you a nasty bite. You don't want to meet that one, a living fossil. Where would you find it? In these blue areas. It's been around for about 80 million years. And then we've got the epaulet shark. It's got its name from the epaulets there. They're not very big. Well, they only go up to about maximum 42 inches. It can actually walk between pools. Again, we find it in this region of the earth, Australia and New Guinea. It comes out at night and can tolerate oxygen deprivation for up to an hour. So during that period, part of its brain shuts down to save oxygen consumption as it's trying to go from one pool to another. And the goblin shark, again, this is the range of the goblin shark. It's been with us also for a very long time, about 125 million years. And it can actually protrude a lower jaw here, depending on what it wants to catch. That's also the same animal. And it's actually catching a fish here, a deep water shark, and maybe the inspiration for Alien, who knows, with that protruding jaw. There's a diver, and that's the size of the shark, and also with the protruding jaw coming out. So it really can change its head shape significantly. Then there's the hammerhead shark. Again, there's the range for it. It hunts mostly stingrays. It does that by using the hammerhead to press them down to the surface, and then it eats them. It can have a very large litter, anywhere from, as you see there, 6 to 50 odd pups. So lots of those get born. Not many survive. Now I come back to the Greenland shark. I said this is an odd one. It's the slowest shark. There it is, up to just over 6 meters long, or 21 feet. It goes very, very slowly indeed, about 1.2 kilometers an hour. That's less than a mile an hour. The top speed's pretty pathetic. You can walk faster than that. It's found up there, obviously from the name. It has very toxic meat. You don't want to eat this particular shark. It's very bad for you indeed. So you've got to wonder, if it moves so slow, how can it indeed catch anything? Well, it can. It sneaks up on seals that are sleeping, for example. It is also the longest-lived vertebrate, the cartilage is there. 400 to 500 years these things have been estimated to have a lifespan. Part of the reason is they're so slow, their metabolism is slow, that they have this long lifespan. A very unusual shark indeed. Then there's the great white, the one that has the really bad rep, of course. Where do we find it? Pretty much everywhere. The blue is the range. You just don't find it right up in the north or just right down here in the south. They're depicted, of course, as the ferocious man-eater in Jaws and other literature, popular media. Well, this is it, breaching. I think you get the point. This is a summary of shark attacks with different countries around the world. This is the total number of attacks. This is a log scale, so that's a scientific scale. So this is 1 to 10, this is 10 to 100, this is 100 to 1,000. It allows me to put a lot of data on the same scale. So really look at these numbers when you're looking at the tops of these peaks. USA, just about 1,000 attacks around the USA. How many were fatal? Around about 15. So it's not, half the height of that. Similarly, here's Australia. How many attacks? That's about 700 attacks. How many fatal? Yes, more. We're getting up to about 80 there. But as you can see, spread all over the world, there is really not that many fatalities when you consider the number of attacks that's taking place. You are 47 times more likely to be killed by lightning, and almost 100,000 times more likely to be killed by an infection when you go into hospital. Isn't that good news? This is the 2017 summary map of attacks. Where you see the blue circles, there was an attack. Where you see the red circles, that was a fatal attack. So one there, one there, one there, one there. That was in 2017. Sharks. I painted them as being, well, at least the big ones, as fairly dominant creatures. Can they be afraid? Do we scare sharks? Yeah, absolutely. Sharks can be afraid. What are the two things they're afraid of, despite ourselves? A dolphin pod and an orca. an orcapod. In fact, it doesn't have to be an orcapod. A single orca can take out a great white. And there is a recorded case of this taking place where the orca basically rammed the great white, stunned it, and then flipped it over it on its back. It put it to sleep, and then it ate it. Simple as that. And it happened really quickly. Extinction. Yes, we are actually worried about sharks going extinct. We see this quote here, which I don't have to read to you. We really would like to stop this, the hunting of sharks for shark fin soup, because that is a big loss of them. But that being said, despite the fact that they are being hunted specifically for a strange dish, they're being caught in nets as collateral damage quite a lot. And so there is that issue to deal with too. How do you fish responsibly without killing sharks just by trying to get food for us? So, yes, this is horrifying if you happen to be in the water and you see that, but really what is more horrifying is the panel over on the right where there's none left because we did that. And that brings me almost to the end. For every human that dies, we're basically killing off 2 million sharks, which is a lot. And that brings me to the end of sharks. 10:15 tonight. Rooftop terrace, stargazing. Thank you very much.